I have a quite long time of activity for free software. I started actively developing free software in 2006 and I'm a member of the Document Foundation since the beginning. And since March, I'm responsible for the project's infrastructure as a freelancer. And also, what I want to notice is that I'm quite a big Python enthusiast. So let's have a look into our current engine room. As you might see from the image, it seems a little bit, outdated. This is because currently we're using a measure of controlled chaos to keep everything running. We have our own dedicated servers, at the moment 6 of them, and dedicated servers rented by others. We have hosted services that run some things like WordPress, blogs and other stuff. And all these things come together and want to be tamed. So for web servers we use Nginx and Apache, we use MySQL and PostgreSQL as database, we have services that are deployed on bare metal, and we have about 29 virtual machines. We use both the uncomplicated firewall from Ubuntu and Chauffeur. Started with the UFB because it was supposed to be simpler, but when the requirements became bigger, we switched to Chauffeur. Postfix as main server, MirrorBrain for managing the mirrors, about 110 of them at the moment. Askbot as a fast-growing question and answer community, known for the templates and extension website. Silverstripe for many other native language websites. And Debian 7 as main operating system, and currently migrating away from Ubuntu 12.04 plus, also running on just half of the machines at the moment. MRVC, mail menu for mailing list management, MLMMJ for public mailing lists, SaltStack for configuration management and orchestration, OwnCloud for document storage, MediaWiki as wiki solution, Dovecut as mail server, Mermon for monitoring our mirrors, Etherpad for concurrent editing of documents, Planet for blog aggregation, and much more. And all that stuff is to be tamed, is to be configured, and needs to be in a defined state. So as you can see, we're using Nginx and Apache, MySQL and PostgreSQL, uncomplicated firewall and Chauffeur. And what we're trying to do is just remove one of them and just do a full switch from, let's say, Apache to Nginx, from MySQL to PostgreSQL. And to reduce the number of servers, to have a more modern infrastructure, and let's see how this will look like. So jumping to the next level, the image is just from the National Factory in US. Taming the chaos. What are our goals in the next step, in the next generation infrastructure? First of all, at the moment we have almost no high availability. We have backups and we will get everything running even if there's some hardware failure soon, but we have no real high availability at the moment. This is one of the most important goals we want to achieve, that half of the hardware can fail and we're still fully or reduced operation. We want to have fewer services that have the same purpose. We just talked about Apache and engines, about 2 different database engines and 2 different firewall solutions. So reducing the number of services with the same purpose eases also the amount of configuration and maintenance needed. So better maintainability. Does that mean? That means that there should be a central point where the whole configuration for our standardized system is managed. This should possibly be done in a repository, so it uses change tracking, so we can see who changed what on our systems. The new infrastructure should make better use of our resources, so it should leverage new concepts, let's say event-based request handling instead of processes, and it should scale easier if we want to grow. So how will we manage to reach these goals? First of all, again, high availability. We want to use current virtualization and storage technologies to develop something like a small cloud platform. And first of all, this needs us to get better suited hardware. We have at the moment different sized servers, and they're just getting to their limits quite rapidly. How to have few services with the same purposes? Quite easy. Find duplicate services and choose the best. So just doing an evaluation, which service is better? Is it MySQL or PostgreSQL? Is it Nginx or is it Apache? For the decision between Nginx and the Apache web server, this was quite easy, because when you see Apache taking up hundreds of megs of RAM and under load, this easily scales into gigabytes of RAM, and then there's sitting Nginx, and it takes its 5 megs of RAM, and then just throwing tens of thousands of concurrent requests on it, and it still sits there and takes up 5 megs of RAM, is quite impressive. And how to get better maintainability is reduce the number of different spec servers. We have, at the moment, we have 8 servers in total, 6 of them rented by us, 2 of them on donated hardware or in other locations. So we want to reduce this number and want to have same spec servers, want to have full control over the hardware, and we want to reduce the configuration complexity. So again, central configuration management, central configuration orchestration, and also to make sure that every virtual machine, every server has the same base set of configuration. How to make better use of resources? Let's simply use software that needs less CPU and less RAM. So this is easy for things like Nginx and Apache. When having a having a short computer, but there are also other things to keep in mind is that many other things integrate well into Apache. So you have mods PHP, for example, and you have to then use via engines fast CGI. So this is also true for other things. In the short term, you might have lower resource use, but in the long term, there might be some bottleneck somewhere else that you haven't seen in the beginning. And looking for simpler configuration, make better use of our human resources, because at the moment the capacity of our admin team is unfortunately quite limited. So if we can spend time making our infrastructure better instead of finding bugs and doing configuration stuff, is better suited. Easier scalability means get hardware that is big enough for running quite a number of machines on them, and make use of an infrastructure cloud provider so that you can easily add more hardware later on if needed, or to distribute the hardware resources between virtual machines. So let's first look on what we will get hardware. So we will have 64 cores, 256 gigabytes of RAM, 4 times 2 terabyte enterprise level SATA HDDs 24x7. Hardware RAID capability, we'll just have to discuss if still going with software RAID or using the hardware RAID. Redundant power supply, and the best is direct connection between two of these machines to get real high availability. So we will have a total of 128 cores and 512 gigabytes of RAM for our new platform available. IPMI for remote management, and really, I have to say, enough both IP4 and IP6 IPs to, for, let's say, forever. So, and what will run on them? The gearbox of our new infrastructure will be overt. At first, I tried to evaluate OpenStack as a cloud solution because of its compatibility with the Amazon Elastic Cloud APIs. But soon I have seen that even with these both huge machines, we're still quite fairly too small for using the full, or leveraging the full power of a project such as OpenStack, where you have about 14 different services that all need to be configured, highly available, and you should need at last 6 of the machines of this size to build a reliable, highly available OpenStack cluster. So looking for alternatives, I soon stumbled across Overt. It's an upstream project from Red Hat Enterprise Virtualization, comparable to Fedora and Red Hat Enterprise Linux. And it does has quite a similar feature set to things like vSphere. So it provides virtual machines, virtual storage, and virtual networks for us on top of CentOS 6.5. CentOS 7 will be supported soon, and the best of all is it will be running in self-hosted engine mode. That means the engine that manages the platform will be hosted on the platform itself. So we don't need to get another hardware some management node runs on, but it is included in in the management engine as virtual machine and made highly available. We use the native support of BLASTFS as replicated storage, and this will allow operation of VMs without downtime, without a single packet loss in a TCP connection between hosts. So also the engine node will be highly available, and in the behind the curtain, Overt uses KVM as virtualization technology. So what drives all this will be, again, SaltStack for infrastructure orchestration. SaltStack is a nice Python tool that has one master commanding a huge number of minions in parallel with quite high speed and low overhead. The configuration is very simple and YAML based, so it takes about 2 minutes to understand the configuration, a little bit more to write your own with dependencies and all that stuff, but you can quite give someone who has never worked with SaltStack before some configuration file, and he will manage to understand it, or mostly understand it. As already said, it's really of impressive speed, and it does parallel execution on an unlimited number of hosts. In comparison with other projects such as Puppet, let's say this is an advantage that should not be underestimated. And one target is that the bootstrapping of the whole platform, including overt installation, engine setup, should be made possible using SaltStack. So you have a bare metal CentOS installation on 2 hosts, and then use SaltStack to bootstrap itself. At the moment, we have quite an extensive set of SaltStack modules and formulas, and we have a new production-ready virtual machine from scratch, set up within 20 minutes, including everything configuration-wise, and installation and updates of the whole software. This is a Debian BZ virtual machine, to be more precise, and at the moment the most work in setting up a new virtual machine is allocating IPs, setting DNS entries, and all that stuff that is currently not done via SaltStack, but via web interfaces while looking into our documentation and stuff. So, and what's also great about SaltStack is that it's very easy to document the configuration of systems, because the YAML-based configuration is quite easy readable and understandable. It is a quite simple way of having documentation. So we also added some restructured text files to our formulas to describe more precisely what our scripts do, and let Sphinx, a documentation generator, run over them. And then we have a nice web page where the open source parts of our SaltStack scripts are fairly well documented. Most parts of these SaltStack scripts are open source, available at GitHub, and the documentation to it is available on Read the Docs, so saltstackspace.readthedocs.org. Yeah?
The slides will be on the website soon, or do you need to write down the URL?
I'll just will publish the slides on the conference site, I think. And where can you find them? Yeah, just
speaker deck account? We have a speaker deck or SlideShare account?
Yeah, we'll just publish it via SlideShare or something like that and make them public. But you can write down. A Google search for solid state space should be enough. You then mostly get to the read the docs website, and there is a quite extensive documentation on how to test and use these scripts on your own. Okay. So now looking at the whole platform, it's easier to give new admins fine-grained access because at the moment we have a number of different services on the same bare metal hardware. As soon as we will have our Infra 2.0 platform, every independent service will be virtualized in a different virtual machine, and it's possible to give different sets of admins access to different sets of virtual machines. So it's easier to give access to new admins that don't get it, should have access to the whole platform. It's easier to maintain because changes to in our master configuration propagate to the whole infrastructure. So it's while having more virtual machines, it's easier to change configuration on all of them. It's highly available. The virtual machines fail over to the other host as soon as enough resources are available. But as you have seen, we have 64 cores and 256 gigs of RAM. So according to some Red Hat paper, this should be enough for about 256 virtual CPUs and 4 terabytes of virtual RAM. So about 200 virtual machines on each server. And this is something we won't reach in the near future, I think. Yeah, the efficient use of the resources, we can scale virtual machines over the size of the host using memory overcommit and using virtual RAM and virtual CPUs. And it's easy to add new virtual machines and add new hardware hosts. It will be as easy as clicking add in a web interface, and the new virtual machine will be set up and provisioned automatically. So the master plan in the next for the next months is to write solid states that provision the overt platform on test hardware, get the hardware from the hoster, provision the nodes, then move at first our existing virtual machines to the new platform, starting with the staging ones, because when they fail, it's not that bad. And then move the services from bare metal machines into separated virtual machines. This means also setting up a whole bunch of new virtual machines and deciding how to separate the services. And then at last do the change from Apache to Nginx, from MySQL to PostgreSQL, where possible. So, and we will have a infra conference call on next week, Tuesday, September 9th, on 1700. And we are desperately looking for new admins and help in all areas. So if you want to join, if you want to help, don't don't wait. Talk to me. Join the InfoConf call. We'll have a posted the number and login credentials on the website list too. This is how you can reach us. And any questions? Yes.
I was wondering if you plan to deploy a large number of virtual machines. Where do you store the virtual disks on these, on the hard disks on the machines, or do you have like special storage backend?
We'll use the normal hard disks, but with a GlassFS frontend. Overt since version 3.3 has native support for GlassFS as storage backend, so there's no POSIX layer overhead as in most other KVM-based solutions, but it can directly talk to GlassFS with a very low overhead. Any other questions?
So do I get that right? You are essentially inviting people to maybe join you, and then you can play on a 64-core 1 terabyte.
And this is quite If you want to have an account on a machine that is that big, talk to me.
You get the first password in the conf call if you join. There will be no recording.
So then it's up to you, Björn. Talking about tinderboxes, I think.
Yeah.